Okay, good afternoon, everyone. I'm Josefina Basquinia, the reporter for today. So, my topic is Advanced Dynamic Programming. So, my topic for today is what is dynamic programming? How does dynamic programming work? Dynamic programming algorithm, example of dynamic programming. So, what is dynamic programming? So dynamic programming is a computer programming technique where an algorithmic problem is first broken down into the sub-problems. The results are safe and then the sub-problems are optimized to find the overall solution, which usually has to do with finding the maximum and minimum range of the algorithmic query. So recursion versus dynamic programming. So in computer science, recursion is the crucial concept in which the solution to problem depends on solution to each smaller sub-problems. So drawbacks of recursion. Recursion used memory space less efficiently. Repeated function calls, created entries for all the variables, and the constants in the function stack. As a values are kept there until the function returns, so there is always limited amount of stack space in the system, thus making less efficient use of memory space. Additionally, attack of overflow error occurs to the recursive function requires more memory than is available on the stack. So where should dynamic programming be used? So that is the dynamic problem. So dynamic problem is a computer programming technique where an algorithm problem is the first broken down into the sub-problems. So these results are safe and then the sub-problems are optimized to find the overall solution, which usually has to do the finding maximum and the minimum range of algorithmic query. So how does dynamic works? So dynamic programming works by breaking down complex problems into the simplex sub-problems, then the finding optimal solution to those sub-problems. Memorization is a method that saves the outcomes of these processes so that the corresponding answers do not need to be computed when your related needed. So save solutions, save time. Okay. So next, so that is the dynamic programming solved coding challenge. So next is the dynamic programming can be achieved used two approaches. So such as the top-down approach and the bottom approach. So the top-down approach is a computer problems are resolved by recursively formulating solutions, employing the answers to the problems, sub-problems. So if the answers of the sub-problems overlap, they may be memorized to keep on a table for a later use. So the top-down approach follows the strategy of memorization. So the memorization process is the equivalent in adding the recursion and catching steps. So the top-down approach is the use to understand and implement. So in this approach, problems are broken down into the smaller parts which help users identify that needs to be done, which each step, more significant, more complex problems, become smaller, less complicated, and therefore easier to solve. So that is the top-down approach. Next is the bottom-up approach. So bottom-up approach, in the bottom-up method, one's solution to a problem is written to term of its problems in the way that loops back on itself, users can rewrite the problems by solving the smaller subproblems first, then using their solution to solve the large subproblems. So, next. Science of dynamic programming suitability. So, which is the overlapping subproblems. So, overlapping subproblems when the answers to the same subproblems. So, are needed more than once to solve the main problem. So, we say that subproblems overlap. So, in overlapping, issue solutions are put into the table so developers can use them repeatedly instead of recalculating them. Next is the optimal subtraction. So, optimal subtraction is the property of the problem, says that you can find the best answer to the problem by taking the best solutions to each subproblems and putting them together. So, look at the picture below. So, that is the advantages of dynamic programming, which is the general applicability, time complexity, optimization. So, of course, we should memorization, space of complexity optimization, so optimal substructure. Okay, next is the understanding of the longing common subsequence concept in dynamic programming. So, in dynamic programming, the base largest common subsequence, which is LCS, largest common subsequence. So, refers to the subsequence that is shared by all the supplied sequences, is the one that is the longest. So, that is, it is a different from the challenge of finding the longest common substring. So, in the components of the LCS. So, do not need to occupy consecutive location within the original sequence to be considered part of the problem. Next is the dynamic algorithm. The dynamic programming algorithm tries to find the shortest way to a solution when solving a problem. So it does this by doing from the top down or the bottom up. So the top-down method solves equation by breaking them into the smaller ones and reusing the answers when needed. So which is the greedy algorithm. Greedy algorithm. So the greedy algorithm, which is 36 minus 20 is equals to 16. So 16 minus 10 is equals to 6. 6 minus 5 is equals to 1. So 1 minus 1 is equals to 0. So that is the greedy algorithm. So let us go to the Freud-Marshall algorithm shown on the picture. Okay, the Freud-Marshall algorithm is the method uses technique of dynamic programming to locate a shortest pathway. So it determines the shortest route across all the pairings and the vertices in the graph with weights. So both directed and indirected weighing graphs can use it. So yun. This program compares each pair of vertices potential routes through the graph. So it gradually optimizes an estimate of the shortest route between two vertices to determine the shortest distance between two vertices as a chart. So that is the example. Okay, the next is Bellman-Ford algorithm. So may kanya-kanya silang form. So Bellman-Ford algorithm works by relaxation. This is a give, so approximate distances. that better ones continuously replaced until the solution is reached. So the approximate distance are usually overestimated compared to the distance between the vertices. So, yan. Shown, yan yung mga picture nila. So, okay, next is the examples of dynamic programming. So, here are the few examples of how one may use dynamic programming, which is identifying the number of ways to cover distance, identifying the optimal strategy of a game. Next is the counting the number of possible outcomes of a particular die rule. So, okay, the takeaway. Takeaway is dynamic programming is among the more advanced skills one must learn as programmer or DevOps engineer. So mainly, if you specialize in Python, it is a relatively simple way to solve complex algorithmic problems and skills. So you can apply as virtually any language or use case. For example, so the viral game, Wordle, so follows dynamic programming principles, and the users can train an algorithm. So to use it by the finding most optimal combination of alphabets. In other words, the skill has versatile applications and must be part of the every DevOps learning kit. So the conclusion of the advanced dynamic programming is a versatile and powerful technique for solving optimization problems by efficiently breaking them down into smaller, so solvable sub-problems by leveraging the principles of optimal substructure and overlapping sub-problems. So dynamic programming algorithm like memorization and tabulation provide elegant solutions to a wide range of computational challenges. So understanding and applying dynamic programming concepts can greatly enhance problem-solving capabilities in various domains of computer science and mathematics. So that's all. Thank you for listening. God bless.